We'll discuss about Huffman coding. In Huffman coding, you will get 2 to 3 marks in gate. Okay, 2 to 3 marks in gate. And what are these encoding systems? How many encoding techniques are available? One is fixed length and the other is prefix. So we will discuss this technique. Huffman coding technique is nothing but optimal prefix encoding technique. And it will do encoding from character to bits, character to binary format. We can say it binary format. Okay, decoding from binary format to character format. Okay, binary format to character format. So how many encoding techniques are available? How many encoding techniques are available? How many are available encoding techniques? So we will discuss about those things. One is fixed length encoding system. In this fixed length, we'll use ASCII values. ASCII values, you know ASCII values, right? A will get some 65, 64 something, from that 95, 96 like that. So ASCII values we'll use in ASCII values code is. Then prefix, this is what we have. This is the Huffman coding, prefix encoding technique. That is nothing but Huffman coding. Here we will discuss about first fixed length Huffman coding, fixed length encoding. It's not Huffman coding, it's fixed length encoding. Then later we will discuss about Huffman coding. Then here there is example of fixed length encoding. Here each character represents with the same number. If A is representing with 2 characters, 2 bits, then B also has to represent 2 characters, but not these, are 0, 1. And other character should be represented with 1, 0, like this. So here with 2 bits, how many possible combinations are there with 2 bits? So 2 power 2, that is equal to 4. With 4 bits you can get only 4 characters. You can define that 0, 0, 0, 1, 1, 0, 1, 1. Only 4 combinations are available with 2 bits. Other than this, you can represent this A, you can say B, you can say C, you can say D. Here, see, observe that. What is, if you want to represent 100 characters, see here you can form a little bit formula, but see, this is very simple one. You have, we'll see this example, then we'll get the formula. See, you have 100 characters. Okay, 100 characters you need to represent. Okay, so how many bits need to represent? See, 100. What is the formula? 2 power 7 is nothing but 128. 2 power 6 is nothing but 64. But how many characters we need to represent? 100 characters. If you take 2 power 6, then it's 64. If you take 2 power 7, it's 128. But you can represent 128 minus 100. It will give 28. So if you take this 2 power 7, then you left with 28 characters. You can use it for other characters representation. Here, see, this is the good example that how you represent these 100 characters. How many bits you need? Take it that log of 100 base 2. That is equals to, it will give 7. I mean approximately 7. It will give exactly 6 point something. But you have to take, you can't represent a bit in either. It should be any, it should not be something in points. So you will take floor value, ceiling value. Okay, you will take 1.6 ceiling value. So it will give 6 point something, 6 point something, and then it will give 7. Okay, ceiling value, you will take it. Then if you want to represent it in 100 log of in n values, if you want to represent n characters, then n, this is equals to base 2 is the total number of bits. It's a total, it implies total number of bits. Okay, total number of bits for n characters. See, we can form that for n characters, n characters, how many bits represented, how many bits required? Log base 2 n bits are required. N bits are required to represent these n characters. Okay, here we'll see what are the pros and cons. Here, pros: easy to decode, it's very easy to decode. Size of message is very large. See, we will see here. See here, this is the message I have. This is the message I sent it to someone, or I received by someone. See, if you calculate B, how many B's are there? 3, 6, 11, 11 and 3, 14. So here you will get 14 B's. Okay, and A's, how many A's are there? 1, 2, 3, 4, 5 A's are there. Okay, then D, how many D's are there? 1, 2, 3, 4, 5, 6, 7 D's are there. D, then Z, how many Z's? 3 Z's are there. X equal to 1. So here total how many characters are there? 19, 26, 29, 30. So total characters equal to 14 plus 5 plus 7 plus 3 plus 1. Okay, which implies total 30. Okay, total 30 characters are available. Here see how many different characters? 5 characters. Okay, 5 characters are different. Okay, in 5 characters are different. So how many bits you need to represent each character? Log of 5 base 2. Okay, which will give 3 bits. So each character needs to be represented in with 3 bits. Okay, total how many characters are we have? Total 30 characters into 3 bits. So it will be 90 bits. Okay, so this is the 90 bits. In this fixed length encoding, what will happen? The message is very large. You can say message is large when compared to Huffman coding.